गुड मॉर्निंग, जय श्रीराम. आत्ता युनिट आपण चौथं शिकत आहे, कन्सेप्ट एक्सप्लोरेशन अँड डेव्हलपमेंट. तर त्याचा सिलेबस बघू आता आपण. टॉपिक्स: सॉलिड मॉडेलिंग ऑफ पार्ट अँड असेंब्ली, प्रोडक्ट आर्किटेक्चर, डिजिटल प्रोडक्ट डिझाईन ऑफ पार्ट अँड असेंब्ली विथ रिस्पेक्ट टू इंजिनिअरिंग ड्रॉइंग, डेफिनेशन, एक्सेट्रा एक्सेट्रा. ऑल ऑफ दिस आर कवर्ड इन दिस सेशन. इथं आपल्याला एक क्वेश्चन पेपर दिलेलं आहे, मोस्ट इम्पॉर्टंट क्वेश्चन दिलेले आहे जे पेपरासाठी उपयुक्त पडतील. तर हे तुम्ही नीट करून घ्या. एक्सप्लेन बॉम्ब विथ एक्झाम्पल. हा क्वेश्चन येणार म्हणजे येणाराचे टॉलरन्स आणि ते सगळं विचारलं जातं म्हणजे जातंच. व्हॉट इज फिट हे पण इम्पॉर्टंट आहे, तर तुम्हीच ते सगळं बघून घ्या. हे बघा इथं दिलेलं आहे सगळं एम पी क्वेश्चन, ते बघून घ्या. सॉलिड मॉडेलिंग ऑफ पार्ट अँड असेंब्ली. तर हा पहिला पॉईंट आहे, आपण सुरू करू आता. कॅड सॉलिड model programs use a database of primitive forms of solid geometry like cubes, cones, cylinders, pyramids, spheres, etc. There are a variety of ways adding or subtracting to produce more complex models.
Oh,
This gives a well-defined model. All volume, surface, and angles are well-defined and known, unlike surface modelers or wireframe modelers, since all solids are represented inside the system as the combination of primitives or parts of primitives. A task like calculating the volume of complex space present few problems. The solid models are representing the geometry and can be the best for engineering analysis because the geometry it will define this interaction between CAD and engineering. More iteration step possible during the design. So many changes during the design process are possible. This will help to optimize the product, which will give an increasing product quality and reduction in the product development time. Assembly modeling further builds on solid modeling by combining solid part models together into an overall assembly model. The individual part solid model data files describing the 3D geometry. इथं आहे ना मित्रांनो, सगळं 3D जॉमेट्री वगैरे असेंब्ली मॉडेलिंग फर्दर व ते असं दिलेलं आहे, ते तुम्ही वाचून नीट समजून घ्या. इथं आपल्याला हे बा इथं डायग्राम दिले, या डायग्राममधून आपल्याला कळतं आहे की ते कसं हे 3D मॉडेल कॅड मॉडेलवर काढलेलं आहे. हे आपल्याला जमलं पाहिजे. पुढं आपण आहे ना प्रोडक्ट आर्किटेक्चरकडे वळू. हा दुसरा पॉईंट आहे. प्रोडक्ट आर्किटेक्चर इज द प्रोसेस ऑफ क्रिएटिंग अ schematic for a product and its various functions rather than representing the product as a prototype. The product is broken down into its base components and expressed geometrically. This makes more apparent and better expresses the relationship between different. पुढचा पॉईंट आहे प्रोडक्ट आर्किटेक्चर डेफिनेशन. द अरेंजमेंट ऑफ फंक्शनल एलिमेंट्स इंटू फिजिकल चंक्स विच बिकम द बिल्डिंग ब्लॉक्स ऑफ फॉर द प्रोडक्ट और फॅमिली और ऑफ products module etc. Other terms for chunks: a chunk is made up of collection of components that carry out various functions of the product. Other terms for chunks or elements that make up a chunk: subsystem, cluster, module, building blocks, interfaces connect these chunks together. The next one is that the architecture. The architecture of a product is the scheme by which the functional elements of the product are arranged into physical chunks and by which the chunks interact. The next is that the product development process: planning, concept development, system level design, detailed design, testing and refinement, production ramp up, platform decision, concept decision, decomposition decision. Product architecture is determined easily in the development process. This is not a linear sequential process. Architecture decision: functional elements, modularity, interfaces, product platform, cost and manufacture, product development, management. The next one is that the choosing the product architecture decision relate to product planning and concept development decision. Product modular product architecture: chunks implemented one or few functions entirely. Interaction between chunks are well defined. Modular architecture has advantage in simplicity and reusability for a product family or a platform. Trailer example: modular architecture.
Integral architecture. Integral product architecture. Functional elements are implemented by multiple chunks, or a chunk may implemented many functions. Interaction between chunks are poorly defined. Integral architecture generally increases performance and reduces or increases cost for any specific product model. Steps to establish the product architecture. These are the steps to establish product architecture. Create a functional model or schematic of the product. Cluster the elements on the schematic. Make geometric layouts to achieve the types of product variety. Identify interaction, fundamental and incidental. Design for assembly. The design for assembly DFA methodology was pioneered by Boothroyd and at the University of Rhode Island. The method is a design evaluation tool that enables designer to. DFA is primarily a cost-saving tool that is concerned with reducing the product assembly cost by minimizing the product part count, the number of assembly operations needed to produce the part, and by making this assembly operation as easy and fail-proof as possible. DFA reduces the number of opportunity to fail in any assembly operation. This automatically leads to improved design and manufacturing quality as well as significant cost reductions. Design for assembly DFA principle. The main principle of DFA to keep in mind are the following: minimizing part count, modularity, built-in fasteners, part symmetry, mistake proofing, use of standard parts, use of reasonable tolerance. Considering all these aspects throughout the product development phase will ensure lower overall manufacturing cost, in turn increasing the potential revenue. While DFA may seem very much produce centric, many of these features will also be appreciated by the end of customer. Design for manufacturing. Design for manufacturing and design for assembly are an interaction of product design and process planning into one common activity. The goal is to design a product that is easily and economically manufactured. The importance of designing and manufacturing is underlined by the fact that about 70% of manufacturing cost of the products are determined by design decisions with production decision. Reduce the total number of parts. Develop modular design for process DFX. Design for sustainability. Design manufacture assembly. Design for manufacturing assembly. Design for reliability. Product design steps. Brainstorming, defining the product, conducting the user research, sketching, prototyping. Company specification, producing the factory sample testing, starting the production development, providing quality assurance. These are the flow diagram of to understand, discuss. Introduction: the ergonomics in product design. Ergonomic is the process of designing and arranging workplaces, product and systems so that they fit the people who use them. Most people have heard or ergonomic and think it is something to do with sitting or with the design of car controls and instrument, and it is, but it is so much more. How does ergonomics work? Anthropometry, body sizes, shapes, populations, and vibration. Biomechanics, muscle, liver, forces, strength. Environmental physics, noise, light, heat, cold, radiation, vibration, body system, hearing, vision. Ergonomics aims to create safe, comfortable, and productive workspace by bringing human ability and limitation into the design of a workspace, including the individual body size, strength, skill, speed, sensory ability, and even attitudes. Economic Ergonomics in product design. Design review, part print analysis. The idea of product design are conveyed to those concerned with transferring them into the physical product using part drawing, blueprints, parts prints. The process engineer must consider the following two important questions in making: what does the product designer want, and what must be done with the information disclosed by the part print to get what is wanted. This step is primarily to exact more detailed information from the part print. Essentially, the process engineer seeks to determine is the general description of the part, the general configuration of the part, the material from which the part is made, how the part originated, recorded changes in design, resistance to damage in process. This is the diagram and their dimension in show classification of engineering drawing, elements of production drawing, bill of material, types of dimension, arrangement of dimensions, etc. All of these are in this. Yeah. So we conclude that our unit 4 is completed. So thank you.